Hello there, this is Arun Gupta. I'm here with Aviran. I'll let Aviran introduce himself.
Hi. Well, I'm a head of backend engineering at Wix. We're leading the DevOps and continuous delivery group, a lot of microservices, and the other fun stuff that we do at Wix.
Nice, nice. What is this Vex thing? I know my son have played with it, but for our audience, give us a more background about Vex.
Okay, Wix is a website building platform. It's basically what you see is what you get. You go into our platform, you drag and drop a bunch of images and into template, and in a couple of minutes you have a working website.
Okay, all right, okay, sounds good. Tell me about your journey for DevOps and microservices.
Well, we actually started as a small, like everyone else, as a small startup uh, with just the standard stack, Monolith with Tomcat, MySQL. And as we grew, we got into a point where our system cannot scale. And that was the point that we did the shift into whole microservices architecture, which actually comes a lot with regards to the continuous delivery move, which we also did. And those two are kind of related. You can't have one without the other.
So you're saying continuous delivery is a requirement to get into your microservices journey.
Uh, At a certain scale, yes. I mean, for the first one, of course, for the one and two first microservices, not. But when you're running tens or hundreds of microservices, I think, yeah, it's a requirement,
Understood. And
especially in the old DevOps culture.
yeah. No, that's important part of it. Now, when you were doing Tomcat MySQL, was it what kind of an application was it?
Uh, it was basically, well, it was everything that we have in Wix. It was the website builder, it was the website viewer, it was serving static file, it was the user logins. Everything was in one monolith, and it really makes us hard to progress. And when you see all those subsystems, you actually understand that they have different scale needs.
Right.
So when you have like someone comes editing the sites, you have, let's say, a couple of millions of users, but those websites now that are published, they have hundreds of millions that are viewing those websites.
Right. Exactly. The requirements for each different component, like viewing versus editing versus publishing, are very different in that sense.
Yes.
Right.
So this was actually the way that we approach the microservices is actually in defining the boundaries of a microservice. Is we actually the first thing that we're doing is defining, okay, what is the service level for each microservice? What is the scalability requirements for each microservice? And that actually helps us defining the scope and the boundaries of each service.
Right. So, would you say a little bit more into the technology? You mentioned Tomcat MySQL. What technology stack were you using for that?
So we actually stayed on Java. Now we're actually 100% Scala shop, but in order to have a lightweight microservice, we switched from Tomcat into Jetty.
Okay.
Uh, because Jetty can run very like in an embedded mode. We actually started with War, and now we're doing like Jar with an embedded Jetty in it.
Right. Uh,
Makes deployment very easy.
and that war was using Spring or Java EE, or what technology was it using?
Yes, we're using Spring.
Okay.
Uh,
So you migrated from a war-based deployment using Spring to a jar-based deployment using Scala now.
yes,
Uh,
and also, I mean, it's still based on Spring, but it's embedded Jetty with a runnable job.
so what's the Scala angle in that case now?
Uh, it, it really has nothing to do with the microservices. It's just that we like Scala very much. I mean, you write less code, and that's pretty much it.
All right, all right. So the technology stack pretty much stayed the same. You were monolith using Spring. Now your microservices using Spring as well.
Yes.
Okay, okay. Now,
And we also split the databases. Instead of having one or two large databases, each microservice, this is again part of us defining the boundaries of a microservice. Each microservice has only one or two tables actually that it's working with. So we can split the tables across multiple databases.
right, right. So now one of the concerns typically people ask in that case is, you have those foreign key referential integrity constraints in a database. If you split your database table across multiple databases where each microservice owns a database, how do you ensure those integrity constraints?
Um, we do it in an application level. We actually use we use a lot of MySQL when you're working in a microservice environment, and basically with large scale system. We prefer proven technology. We could go to like NoSQL and all the other fun stuff, but when you're working at a large scale, the first thing that you need to consider is if something breaks, how fast can I bring it up,
Right,
and do I
right.
have all the knowledge in place?
Yeah,
So we're still using MySQL, but we're using it as a pattern as a NoSQL. So we store a lot of key, we denormalize a lot of data, and we use a lot of key value operations on MySQL. And we try not to have a lot of relational references between tables. We
right.
just do a lot of denormalization.
Yeah, 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 yeah. So denormalization is really the key, what you're telling me, for splitting up your database into multiple databases.
Yes.
Okay. Now, you started from a monolith. You did sort of the functional decomposition that, okay, web editing is one part, viewing is one part, publishing is the other part. From one monolith, how many microservices did you create as part of that?
During the transition phase, we created with about five from this monolith. We created five, and as we evolved from those five, we basically created like 20. After that, so we created not like microservices, but more of a services, like more larger services.
Right, right.
And as we went along, we just created more and more. Right now, we have over 100 microservices in our production environment, which about half of them we created just last year.
Nice, nice. Now, typically when you talk about microservices, people say, oh, micro means less lines of code per service. Did you had any such constraints, when you were building a microservice? Or what do you think micro refers to?
Micro is basically an area of responsibility.
Right,
It has nothing to do with the lines of code. We have large services, large microservices, and small microservices. The smallest one is basically a time zone microservice. All it gets is an IP address and returns a time zone.
right,
So that's like smallest microservices, and we have large ones that have a really big domain, like our HTML editor. It's a fairly large microservice, but it has a lot of functionality which makes no sense in
right,
splitting it up.
right, right, right. So I agree with you that, it's in that sense it's more functional microservice. The scope is micro, but the lines of code is by no means any measure of microservice.
Correct.
Right. Okay. That's good. Now, so you say you have about 100 microservices running today.
Yes.
Okay. And are those all using Spring and Jetty?
Yes. All of them are using Spring of Jetty. We actually have a couple that actually on a different stack. When we were working in a microservice environment, I mean, we decided, and from our experience, it's very important to keep a standard stack that everybody works on the same framework, because you have the same concerns, like you have like encryption keys and session validations and on all those things that are shared. So it's really important to work on a single stack and a single framework.
Yeah.
However, some microservices have like special needs and special requirements that are out of the stack. So we have code running in C, and some was in PHP from like open source projects that open source systems that we had to take. So we have a couple of like outsiders, but most of them running on the same stack.
So now, you said you have something in PHP, something in C, something in Spring, something, So it's in that sense, it is a polyglot stack. So how do you communicate between those services?
We opted for JSON over JSON RPC over HTTP. We did a bunch of tests. We actually started with the binary format, but as we grew, we understood that it's very important for us to debug the transport and see what actually is on the wire, and to go into curl and actually submit requests. So we made a bunch of tests, performance tests, and we saw that actually JSON over RPC is pretty fast. For our needs, it's good enough. So you can implement that like on any stack and actually debug and see that it's working.
So you use JSON over RPC as opposed to JSON over HTTP.
It's over HTTP, JSON RPC over HTTP.
So give me more details about JSON RPC.
So it's basically a JSON payload using standard HTTP client. We use JAXB. I'm sorry, Jackson. We started with JAXB and moved to Jackson to parse the JSONs. We actually do like signings and stuff to have a secure communication. We have two different communication stacks. So from communication from the outside of our data center is actually REST, and inside the intercommunication inside the data center is it's JSON RPC.
Okay, I got that. Okay. Now, how do these services discover each other? How do they talk to each other? Because a given service can go down, come up, come back up. So how do these services discover each other?
Actually, we started running. We built everything in our own data center. So basically, we let the load balancers handle all the discovery. So it's basically a DNS names. So once you have the DNS entry, you call a URL, and one of the services on the cluster just get the request. So we don't really need a service discovery. All you have is a config file with a topology that tells you, okay, these are the topology that I need to talk to whatever microservice that I depend on.
Okay, so you completely bypass the service registry and discovery. You just rely upon the DNS itself to do that, registration and discovery.
Yes. It makes life very easy.
Yeah. Okay, no, I think that's a very good point, because a lot of times people, when looking at microservices, they do talk about the service registry and discovery. All right, that's very good. Now
we tend to keep things very, very simple. I mean, we only now that we have like 100 microservices, only now we're starting to think about putting a zookeeper for like configuration and service discovery. But when we started, we kept things very, very simple in order to see, do we really need it?
Right.
And we discovered a lot of things that people are talking about, like the service discovery and a central configuration system. We don't really need it. You can configure it via XML files, and deployment is done using Chef. And part of the deployment process, Chef compiles the configurations that have placeholders, put everything there, and just deploy it.
Nice. Nice.
and
Yeah.
and it's very important to keep dependencies between, since you're working in a network and things happen in the network. You want every microservice to be independent and be able to work without with as minimal dependencies as you can, and those are just extra dependencies that we don't need.
Right.
So if you can just put an XML file with the deployment system, with the deployment, then everything should work fine.
Right, right, right. Well, this only reminds me of the Martin Fowler's article about Yagni. He says, "You ain't gonna need it." So if you don't gonna need it, don't build it. Basically, worry about it when you
That's
really gonna need it. And I like the simplistic approach, which is basically the KISS principle. Keep it short and stupid. Simple and stupid rather. Let's start simple. Let's get something working. If you have scalability issues, then you look at it and then you evolve it.
Yes, and that's basically the how we do things.
Really good, really good. Now, tell me more about your. You kind of started talking about that a little bit, Chef. So you use Chef as a configuration management tool.
We use Chef as a configuration and deployment management tool. We build a lot of tools around it. We built our own, we call it the lifecycle system, which manages all the build and deployment and triggers the Chef process to run. Uh, we build a lot of helpers that enables Chef to actually get all the configuration from. We have a central configuration system. It's basically a glorified database that we put all the entries for the microservices, but every microservice just define its own dependencies, and then every Chef run, it takes those configuration value and sticks them in the configuration file and just deploy it.
Right, right. So are you saying that Chef by itself is not sufficient and you need those tools anyway around it?
Yes, yes.
Okay, okay.
Mostly in making Chef accessible for developers, so for
Right,
self-service. We
right,
don't want like 100 developers or 300 developers having to learn just one more tool
right,
just to do the deployment. I mean, if you
right,
can
right.
put like a nice UI in front of it and have them self-service.
Yeah, I think you mentioned a very good point, which is self-service infrastructure, where developers, whenever they want, whatever they want, they can click on that buttons and say, "What I want this," and that is automatically provisioned from them. You happen to use Chef in the background, that's all right.
Yes, exactly.
Okay. Now, what kind of a CI tool did you use?
We use TeamCity as
TeamCity. Okay.
a as a CI. It's the problem with CI and TeamCity and most of them that we have is that you have the build dependencies, which is using Maven, and you have the actual deploy dependencies. And in a microservice world, I mean, you have basically an API that's calling another microservice, but it's not being represented in your build system. So you have to build like the rule. Okay, once I build this microservice, in order for us to run all the tests, we're working with TDD. So you want all the dependencies also to be run. So
Right.
we so that's a pretty challenging task to synchronize between the build dependencies and the deployment and the test dependencies
Right.
basically.
Right. 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 Now, why did you choose TeamCity? I mean, I generally when I talk to people, they using more like a Jenkins or some that sort of an install. What feature did you like about TeamCity particularly?
It's not that we like anything in particular in TeamCity. I mean, we started very early. I mean, before even there was a Jenkins,
Oh wow. Okay.
we already had TeamCity, and we just continued with it.
Yeah, that makes sense. There is no point to be disruptive. If the tool that you already have makes sense.
Yes, and it's working fairly good for us.
Very good. Very good. Now I'm happy to hear that. Now, in terms of the continuous delivery, which is what we mentioned about earlier, have you built a deployment pipeline using TeamCity?
Yes. using TeamCity and Lifecycle, this is our own internal tool that actually orchestrated everything. So we initiate the build from our lifecycle system, which triggers TeamCity, which then triggers Chef, so we build the pipeline. Whatever we can do in TeamCity, we do in TeamCity, but we have this lifecycle tool that actually orchestrates the whole process and synchronize between those different tools.
Right, 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 right. So you can do a full push to prod using TeamCity, Chef, and your tools, lifecycle tools.
Yes, basically, just one click of a button.
Okay. Oh, that's very nice. That's very impressive. And so I want to emphasize the fact it's 100% automated in that case.
Yes, it is 100% automated. We actually do we do it in two steps. So first, we create a release candidate for some of the projects that we want to deploy into staging. Mostly projects that have a UI in front of them. So we want to be able to have maybe a manual QA sometimes.
Right.
But for all these server artifacts that don't have any UI involved in it, most of the microservices don't have UI, so it's fully automated. We skip the staging, we just deploy to production into a canary, call it testbed, and see that everything works and continue from there.
So you do canary testing and A/B testing as well?
Yes, we do all of them. We actually developed a tool called P3, which we open source, that manages all our A/B testing and feature toggles, feature flags, and configuration. And it's actually defined. I mean, this tool actually defines the way Wix works.
Nice.
We're very data oriented. We don't release anything without testing it first. 100% of the features are going into A/B tests.
So metrics and monitoring is a key part of this entire process in that sense.
Yes, of course, and not just in terms of A/B testing, just in terms of you have a lot of microservices in production. You have to be able to see what's going on with them.
Right.
And in every team is responsible for their own services, and the fact actually that they're all working on the same stack, so teams can cover for each other, because if something happened in the service, even that they don't own it, since it's the same stack, it's very easy to debug. I mean, you know where the logs are, you know what framework you're running on. It's just that the business logic may be different, but to debug production problem, most of the time, the business logic is less relevant, and everybody can read stack trace.
Right. So I think what you're telling me is the fact that you consciously chose all these microservices to be written using a standard stack really helped you as opposed to going a polyglot environment.
That's correct. Yes. Again, especially we don't have like a level 3 or level 4 support tier. I mean, it's the developers themselves that are always on call, and people want to go on vacation, and other teams just cover for them, and everybody covers for everyone.
Yeah. Okay. Now, your entire infrastructure, is that running in your data center or in a public cloud?
We actually run in both. We started everything in our own data center. Some of our services, especially, again, it depends on the service level for each and the scalability requirement for each service. So some of them are also running in the clouds, on some of them running in Amazon, some of them running in Google, some of them running in both our data center, Amazon and Google. So it really depends. But most of our services running on our data center.
Okay, so you truly have a hybrid approach in that case. Have you seen any advantages or disadvantages of using that hybrid approach?
The disadvantage is you have to write. The problem is with replicating data across those different providers. You have to work really hard in order to make those replications. But there is a huge advantage in doing so, because since those clouds are out of your control, and we really care about our customers, we and Amazon have problems, Google have problems, everybody have problems.
Sure.
And once you have an issue, let's say with Google, and there's nothing you can do about it except open a ticket and then hope for the best that they'll fix it in time. Having those services running in two different clouds, we can always shift traffic to the one that's actually that's working at the moment.
Right.
And when everything comes back together, we can split the traffic again.
Yeah.
So we do traffic shaping.
Well, the critical part is, you talked about that already, in the sense you don't want the service experience to go down, or at least, you don't want the service to go down. The experience may go down a little bit. That means the user may experience a little bit slowness, but the service never goes down completely. That's the advantage of the hybrid cloud.
Yes, always available. I mean, the chance are that both Google, Amazon, and our data center will go down is like very slim.
I agree on that. Yeah. No, that's very good, actually. Okay.
But we don't do it for every service. We only do that for like our critical part of the services.
Sure.
Some of them, because it's very expensive to do it.
Oh, absolutely.
So,
absolutely. I agree with that. Okay. Now, this is wonderful, actually. This is wonderful. Now, tell me more about the cross-functional teams. People say for a microservice you need a cross-functional team. How did you go about that, or do you guys really follow that?
It's not really a microservice. I mean, it's more, it comes from the continuous delivery DevOps approach. We actually have, all our developers have production access, and they debug their own services. They're responsible for their own services. They have a lot of help from the system team, but it's mostly their responsibilities. Also, with regards to product managers and front end developers, I mean, we try to have those together. At some teams it was a success, and some it wasn't. Mostly in terms of you have different concerns when you're developing front end application with rich UI,
Yeah.
and very hardcore server side processes. So
Yeah.
since they have to cover for each other, I mean, most developers tend to group. Okay, we are the server team because we need to take care of production, and we are the front end teams, and we need to make the UI very beautiful. And sometimes it's working together, but most of the time we saw that as hard as we try to make those connections, I mean, they always split back because they share common knowledge between
Right.
backend and system more than like front end and product.
Right. No, I understand that. So, what would be the hardest part, when you were transitioning from a monolith to a microservice-based architecture, would be in that case?
The hardest part is actually learning how to write good tests.
Very well said. Very well said.
Our monolith, of course, wasn't tested at all, and we actually tried to learn how to do like TDD and writing all the tests. We were crappy at this at first. I mean, we're pretty good at it now. Again, and even when we split the monolith to like the services, I mean, it took us like 2 years to complete the transition.
Wow. So from a monolith to a microservice transition was a 2-year effort at Wix.
Yes, until we actually killed the monolith. Because you always have those parts that, okay, if I'm writing a microservice, I'm actually doing a rewrite. So on the process, you have like deprecated functionalities that you don't want to migrate, and you leave it to the end. And so but you already have customers that are using it with data that is not being used on the new system. That's what actually took a long time to actually do the deprecation.
Yeah, yeah. So, how much of the code from the monolith was repurposed for writing these microservices?
Actually, most of it, I think, like about like 80% was rewritten. About 20% was deprecated and eventually gets scrapped.
Nice, nice. Yeah, that's actually a very good reuse. So, in that 2 year of time period when you were refactoring, where do you think the biggest amount of time would have gone?
Um, writing writing the right infrastructure, um, because writing the framework and understanding really what we need. I mean, the first thing that we did is not actually writing the microservice. The first thing that we did is thinking about what is the infrastructure, what is the framework, the common framework that we want for our microservices, and that will support continuous delivery and DevOps.
Right.
So we build a lot of tools to help developers access production and debug their application without having to go into SSH and reading log files. We don't really believe in log files because most developers don't know how to write a proper log file. Just copy paste something that they found on the internet and stick it in logback.
Yeah.
So we build a lot of the framework, and only then we started to write the actual service.
Right.
In the beginning, we wrote like a smaller monolith, and only then we separate that into another more microservices out of that smaller monolith.
So, in terms of the process, you took a big monolith, you wrote a small monolith, and then you started refactoring it into multiple microservices.
Correct. Yes, we just took like an entire domain. So we took like if something is related to user authentication, so we took everything that is user authentication, we put it in one monolith. So and everything that regards to website editing, we put it in one monolith, and everything that's and serving website, we put it there. And from there, we evolved into more. We refactored that into smaller microservices.
Nice, nice. Yeah, that kind of makes sense because you are taking one step at a time. You take a bigger monolith, chunk it into smaller monoliths, and then you say, and I'm going to take a step two. Now that my functionality is up, and then I'm going to split it into multiple microservices and look at the repurpose and reuse.
Yes, it's both functionality and actually learning how to operate and what are the problems, because now you have network issues and you have to put like throttlers and retries. I mean, it's not like when everything's running in the same process, you don't have those networking issues.
Right.
So you had to learn how to cope with this and what are the tools that are going to help us. Now you have distributed transaction, you have to cope with that. You have to put like more monitoring tools, and so we started small and only then evolve. We didn't just jump. Okay, we're gonna write like tens of services, and then once everything in production, you say, "Oh my God, we don't know how to manage all those things."
That's a good point. Yeah. Now you talked briefly. You touched upon that topic of distributed transactions. How do you do distributed or a two-phase transaction in microservice world?
Um, we actually do basically from a database perspective, we do logical transactions. So for example, if you have like invoice has like line items that you want all of them to be saved in the same transaction.
Right.
So what we do is we create a logical transaction. We save every line item separately, and it can go to any server in the cluster. So everyone saves them independently. And only when all the line items are completed, we save another record which basically points to all those line items that were saved.
Yeah.
So until this header is being saved, I mean, this actually makes the transaction. So if everything fails in the middle, the only thing that you have is like orphan records in the database that nobody cares about them.
Right.
Until this one record that points to everything else.
And then possibly at the end of the day, you can clean up those records as well, just to save space.
Yes, Yes, if we care about space,
Yeah, yeah,
we
yeah.
can.
Awesome, awesome. This is really good. This is really enlightening. Now, in terms of your DevOps journey, what was the biggest challenge?
The biggest challenge is to have developers access and understand their application on production. And actually, what we found the best uh, tool that we found is actually putting large monitors in every developer's team with the monitoring system in front of them.
Yeah, yeah.
So they come to the office, they see their application, and they see how it behaves on production. We have a very nice story about that. That one day, one of my developers go into the office, and he looks at the screen and he says, "There's no way my service responds in 15 milliseconds. I mean, this is too slow. I can't live with that." And a week later, it was like 20 milliseconds,
Nice.
and nobody told him to do it. I mean, he
Yeah.
just looked at it and he said, "Well, it's too slow. I can make it faster."
You feel guilty of writing that service. Oh, that is funny. That is funny. Abhiram, this has been absolutely wonderful. I learned so much from you. This has been really, 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 really useful. So, what I'm going to do is, first thing, I'm going to stop the recording. Before that, I really want to thank you, and I hope you guys have a good time at Wix. Thank you for sharing this knowledge. So, let me stop the recording, then I'll chat for you for a minute as well.
All right.